In this session, we will discuss about the addressing modes of 8051. 8051 is a microcontroller. So, before going with the addressing modes of 8051, let us understand the instruction. Instruction consists of opcode and operand. So, if you see, it consists of an opcode and operand. So, we will try to know what is an opcode and a operand. Opcode is an operational code which consists of the information of which operation is to be performed. For example, addition, subtraction, multiplication, division, move, rotate, clear, set. These are all the operations, the type of the operation to be performed. Next, operand. The operand is a data on which the operation is to be performed. For example, add a comma b. Now add comes under the opcode a comma b. Here the operand is in the form of a register name. The data will be placed in a register and the name of the register is a part of the instruction. So this is about the opcode and operand. Opcode and operand both will form a instruction. And then addressing mode. The way the operand is specified in the instruction is known as addressing mode. Means how the operand is given in the instruction. Either it is immediately available in the instruction or it is placed in a register and the name of the register is part of the instruction, or it is placed in a memory location and the memory location address is the part of the instruction, or usually a register is taken to point to the data. So, depending on how the operand is given in the instruction specifies the addressing mode. There are 5 addressing modes in 8051. Immediate addressing mode, register addressing mode, direct addressing mode, register indirect addressing mode and indexed addressing mode. So, let us begin with the immediate addressing mode. In this immediate addressing mode, as the name indicates, the data is provided in the instruction itself. Your controller need not fetch the memory or anything, directly it is part of the instruction. Move a comma hash 0AF. So here if you see, after the microcontroller executes the instruction, the A will be, the accumulator will have the AF. AF data will be present in the accumulator. And move R3 comma hash 45H. So here 45 is the immediate data available in the instruction, and once the microcontroller executes it, the R3 will have, after the execution, the R3 will have 45H. Move DPTR comma, the third example, move DPTR comma hash FE00H. Unlike the A and R3, DPTR is a 16-bit register. So, the operand is also, the data is also 16-bit. So, after the execution, your DPTR will have the FE00 will be moved into the DPTR register. And the points to be remembered are, whenever we are going with the immediate data, hash symbol has to be used. And whenever the data is starting with A to F, it has to be preceded by 0. See here, for example, it is preceded with 0. Register addressing mode. In register addressing mode, one of the 8 registers R0 to R7 is specified as operand in the instruction. So, we all know that 8051 has got 4 banks, bank 0, bank 1, bank 2, bank 3. Each bank has got 8 registers R0 to R7. Bank 1, R0 to R7, bank 2 and bank 3. Now, in this addressing mode, the data is placed in one of the bank registers and it can be moved to accumulator register. So, for example, and how to select the bank? By programming the PSW register, we can select the bank. By default, always it would be bank 0. So let's go with the examples. Move A comma R5. So what does this move A comma R5 does? Whenever the microcontroller executes this instruction, the content of R5 will be moved to accumulator register. Whatever may be the content of R5 will be moved to accumulator register. For example, R5 has some 0A. After the execution, accumulator will also have 0A. Move R0 comma A. Move R0 comma A, the content of accumulator will be moved to R0 register. In 8051, the point to be remembered, in 8051 there is no instruction like move R5 comma R7. Means what? There is no, we cannot transfer the data between two bank registers. Between any two bank registers we cannot we cannot move the data. Next, direct addressing mode. In direct addressing mode, the address of the data is specified as the operand in the instruction. Using direct addressing mode, we can access any register or on-chip variable. This includes GPRs, RAM locations, special function registers, IO ports or control registers. So to understand the direct addressing mode, for example, the first one, move 80H comma R6. Before execution, assume that R6 is having some AA before execution. And after the execution, what happens? The content of the R6. What is the content of the R6? AA will be copied into the RAM location 80H. In the RAM location 80H, AA will be copied. The content of the R6 will be moved into the RAM location 80H. And second, move R2 comma 45H. So before execution, assume that in the RAM location 45, there is some data BB. So after execution, what happens? The register R2 will have BB. The content of the memory location 45 will be copied to R2. Register indirect addressing mode. In this register indirect addressing mode, the address of the operand is specified as a content of a register. So now the address of the operand is specified as the content of a register. Means what? The data is placed in the memory location and the address of the memory location is placed in the register and the name of the register is part of the instruction. So move 0EH comma @R0. So what does this mean? Whatever the data pointed by the R0 register, the data pointed by R0 register will be moved to memory location E5. And with the second example, move @R1 comma 80H. 80H is a address. So the content of the 80H, whatever may be the content of the 80H, will be moved to the memory location pointed by the R1 register. So we use the two braces here to indicate the content of R1 register, because R1 is going to have a memory location value and in that memory location the data has to be moved. The R0 and R1 are used for 8-bit addresses and DPTR is used for 16-bit addresses. No other registers can be used for addressing purposes. And next point is in this addressing mode, The @ symbol is used for register addressing mode. Register indirect addressing mode. Now next is here move x a comma @r1. So now this is for your external addressing. Always x indicates the external data memory. So move x a comma @r1 means what? The r1 is going to have the memory location and the data from the r1 memory location will be moved to the accumulator register. And next move @dptr comma a. The content of accumulator will be moved to the memory location pointed by the dptr register. So this is about the register indirect addressing mode. Next, indexed addressing mode. With indexed addressing mode, the effective address of the operand is this is very important. The effective address of the operand is the sum of the base address, base register and the offset register. The base register can be either data pointer or program counter, while the offset register is the accumulator. So move c a comma @a plus pc. Usually this addressing mode is used for lookup tables. Most of the time we see this in the whenever we need to access the data from a lookup table. Move c a comma @a plus pc. So the memory location pointed by the sum of accumulator and the pc. The data pointed by the memory location, that is nothing but the sum of a plus pc, accumulator and pc. The data will be moved to the accumulator register. The C stands for code. Next, move C a comma @a plus dptr. So here again the content of the accumulator plus dptr. First we perform the addition. It is going to go with the memory location and the content of the memory location is stored in accumulator register. Always the destination will be accumulator register. So with this we complete the addressing modes of 8051 microcontroller.